Okay, let's start. Jamb candidates, welcome to today's lesson. And today we are looking at soil types and characteristics, okay, as specified, recommended, suggested by Jamb in her syllabus. The table we have on the screen, we have the column for the features, and the column for the features is on a black background. And we also have the types of soil, which include sandy, loamy, clayey, and all these are the column for each of the types of soils, okay? Okay, this for sandy, this for loamy, and this for clayey. We are going to look at all the features and characteristics of the soil, okay? What is the particle size of sandy soil? Okay, the particle size is between 0.02 to 2 millimeter largest, and it's the largest sandy soil, okay? It's the largest. Just know that sandy soil has the what? The largest particle, okay? It has the largest particulates, all right? And for the loamy soil, it's mixed, 40% sandy, 40% silt, and 20% clay. Don't forget, loamy soil is mixed, 40% sandy, 40% silt, and 20% clayey. And the clayey soil has the smallest. That's why it's very smooth. It has a fine texture. All right, it has a fine texture and it's smooth. Okay, especially when it's soft. When you wet it, it's smooth. So it's about 0.002 millimeter is the smallest. So what is the texture of the? So what are the textures of the different soil type? Okay, sandy soil has a gritty or coarse. It has a gritty or coarse texture. Okay, like the texture of salt or the texture of sugar granule. Okay, then for loamy soil, it has a crumbly smooth texture. Crumbly smooth texture. Okay, it's not so smooth, but it's a bit smooth. Then you have the clayey soil, which has a sticky, sticky texture when wet, and it has a hard texture when it's dry. That's why you use clayey soil to build house. All those kind of houses you call mud house in the old. Okay, that's what they used to build house in the old, mud houses, mud soil. All right. I think in ancient cities like Benin City, okay, Benin City and some part of, let me say, Edo State, you still have some mud houses there. Okay, so if you want to see a mud house, you can go to Benin City or Edo State. I think you can still see some few areas where you have mud houses there. All right, so looking at the structure as a feature of each of the soil types, sandy soil has a single grain structure. Okay, it's very loose. The structure is very loose. That's why you can't put it together. You can't put sandy soil together. It cannot hold water because its grains are not close. They are not closely packed together. They are separated. Okay, it can't hold water. Okay, and it has a very high porosity. That's why I can't hold water. Okay, so for loamy soil, you have crumb. Okay, aggregated. It holds water to some extent. Okay, it forms crumb. It can form crumb. All right, that's why when you are planting, when you are making ridges, you are going to be seeing crumbs of loamy soil. All right, then for the clay soil, is granular and is platy, clings together, they come together. It has a very low porosity. In fact, it has the lowest porosity. Okay, among the three of them. Okay, it holds water. Okay, water no dey fit dey pass through. So if you pour water put, if the soil soak water, it dey hard before the water dey come out. It dey hard before the water dey come out. So let's look at porosity as a feature of the three soil types. Okay, the porosity of sandy soil is very high because it has large pores. Remember, the grains are loose. Okay, they are not tightly packed together. And you have loamy soil with the moderate porosity. Okay, it's moderate. It's not too high. Remember, loamy soil is the mixture of sandy soil, silt, and clayey soil. So it's going to possess the property of sandy soil and also the property of clayey soil. So loamy soil is in between. That's why you can see loamy soil in the middle of sandy and clayey soil. It's in between them. All right. So it's intermediate. So the porosity of clayey soil is very low, small pores. Okay, that's small spaces for water to pass through. That's why it can hold water. Clayey soil can hold water for a long period of time. For sandy soil has low capillarity. Pour water rise, you know, they hold water, okay, because it's very porous. Okay, loamy soil has a moderate, while clayey soil has a very excellent water rise because it holds water. Still under soil characteristic, okay, the feature under water retention feature. Sandy soil has a very poor water retention feature. It drains fast because it's highly porous. Loamy soil has a good and balanced water retention capability. That is why it is used in planting. Okay, it's used in cultivation, agriculture. Okay, while clayey soil has a very high water retention capability because it has a low porosity. Okay, it holds water tightly for a longer period of time. Let's look at the aeration feature. Okay, for sandy soil, it has an excellent aeration. Okay, for loamy soil, it has a good aeration. While for clay soil, it has a poor aeration because it's waterlogged. Water too much for inside, so it cannot easily be aerated. All right, it cannot easily be aerated. It's waterlogged. Okay, it's swampy. Okay, when you hear waterlogged, you know swampy. Okay, so humus content. For humus content, sandy soil has a low humus content. It's fast decomposition. That's why it has a low humus content too. Okay, because humus content, we all wash come out. You know that humus content in a loamy soil is the first part of the soil, usually located at the topmost of the soil. very essential for plant growth. Okay, so in loamy soil, it has a very high humus content. In fact, it has the highest humus content. That's why it's ideal for agriculture and planting. It has the ideal accumulation of humus. Okay, then for clayey soil, it has a moderate humus content. Moderate. All right. So what is the workability? The workability. How well can we use these soils? Okay, using sandy soil is easy. It's easier to use sandy soil. Okay, for loamy soil, it's easy. It's also used best for crop. It's used for crop. But for clayey soil, it's difficult because it's sticky and it cracks. When it gets dry, it cracks. Remember, sandy soil, you can use it to build houses. Okay, but you can't use clayey soil to build houses. Even though you mix cement join them, it will still a crack. Okay, but this clay soil, you don't just get waiting good to the use and the do. Even for molding itself, sculpture is not even good. So it's not suitable. It's very difficult to use. Okay, but I think clay soil is used for molding. Okay, they usually mix it with some chemicals and use it for molding. All right, so that's that for that. Then best for crop, for sandy soil, root crops, okay, and groundnuts. So root crops, all those crops where we say their food, they store for inside their roots. Sandy soil is best for them. Okay, they thrive well in sandy soil. Jamb asked me this question. Okay, Jamb said this question for me during my first Jamb. Okay, Jamb said this question during my first Jamb. They asked the question like this. They said, what plant thrives well in sandy soil? So I was able to pick the correct answer and move ahead because I know one. All right, so for loamy soil, most crops thrive in loamy soil. Okay, but maize, vegetables, they thrive well for loamy soil. While for clay soil, you have crops like rice, wheat, and sugarcane. These are the crops that thrive in clay soil. Okay, rice, wheat, and sugarcane. Now, it is important that after treating what we just treated, soil and its characteristic, you have to note something very important, very, very important. Particle size versus capillarity / water retention. Inverse relationship. It has an inverse relationship. Though I explain it, but I want you to understand it. Particle size. When you have a smaller particles, when a soil has smaller particles, it equals higher capillarity and water retention. For example, you have loamy soil having what? Smaller particles. You have clay soil having the smallest particles. So this is equal to high capillarity and high water retention. Okay. So for sandy soil that has a larger particle, it has a low capillarity and low water retention. You can see. So inverse proportion. Okay. So particle size versus porosity / aeration. When the particle size is higher or the particle size is larger, it equals high porosity and aeration. For example, the sandy soil that has a large particle, okay, large particles, that equals what is directly proportional to what? Porosity. Large particle, large porosity, or high porosity and aeration. As simple as that. ABCD. Now here, Jamb, the set questions well. Now let's look at the soil components. Okay, we have the components, we have the volume by percentage, we have the percentage by volume, we have the key elements found, and we have the functions. All right, now let's look at the first, which is what? The components of the soil, which is inorganic. We have the organic and inorganic components. The inorganic components makes up about 45% of the soil by volume, and it consists of sand, silt, clay, minerals such as, what are the clay minerals? You have minerals like nitrogen, phosphorus, potassium, calcium, magnesium, and so on and so forth. So the macronutrients. All right. So for the functions, what are the functions of the inorganic components of the soil? Anchorage. What is anchorage? Anchors the soil, puts the soil together, okay, or keeps the soil together, okay, maintains integrity. That's anchorage. So mineral nutrition. Remember, the inorganic component of the soil has all these minerals, the macro minerals, okay, and also texture. So because it helps in anchorage, it also determines the texture of the soil. The next one is organic component of the soil, known as humus. That uppermost part of the soil. It makes up about 5% of the soil by mass. All right. And what are the key elements? Decomposed plant / animal matter. All these serve as manure. Okay, that's why humus is the richest part of the soil. Okay, and what is the function? Nutrient supply, water retention, because it has a fine, texture, small particles. Okay, and pH buffer. Okay, it helps the soil to resist slight changes in pH. Still under the components of the soil, you have soil organisms, and the percentage by volume is variable. Okay, it changes depending on the particular soil. Okay, the elements found include bacteria, fungi, earthworm, termites, and so on and so forth. The functions include decomposition. Remember, it is through decomposition that the soil is nourished. Okay, it is through decomposition that the soil is nourished. The soil regains its minerals. Okay, or the minerals in the soil are replenished. Okay, so decomposition, nitrogen fixation, aeration, and mixing of the soil. These are the function of the soil organisms. Okay, usually microorganisms, and sometimes earthworm, termites. I already explained to you how earthworm uses burrow to maintain soil fertility. The next is soil air. All right, soil air makes up about 25% of the soil volume. Okay, soil air is a component of the soil that makes up 25% of it, and it consists of oxygen, less than the one you have in the atmosphere. Okay, so the oxygen in the soil is less than the oxygen you have available in the atmosphere. You have carbon dioxide, which is more. Okay, it's more. Carbon dioxide is more in the soil than oxygen. All right, so what are the functions of these, these key elements found in soil air? Okay, is for roots, respiration through roots, and microbial activities. Remember the plants that respire through roots. Can you remember the kind of plant that respire through roots? Where are they found? They are found in swamps. Okay, mangrove swamps. That's where you have them. They respire through. They have breathable roots. Okay, pneumatophores. That's what it's called. Pneumatophores. Then the final we have here is soil water, which makes up about 20% of the soil by volume, and the key element is gravitational, capillarity, and hygroscopic. Then what is the function, or what are the functions of soil water? Nutrients, solvents. It acts as a solvent, okay, as a medium for chemical process, biochemical process to occur. Okay, so it's the nutrient solvents. Now inside that water, and the nutrients they dissolve. Okay, it also helps in photosynthesis and also turbidity. Now let's look at the causes of the loss of soil fertility. What makes the soil to lose its fertility? What are the causes? The first we have here is leaching. Rainwater washes nutrients down, especially in tropical soil. Okay, leaching, leaching of nutrients from the top part of the soil, or the uppermost part of the soil, down inside the soil. Erosion because of these things. Okay, so leaching is one method at which the soil loses its nutrients. Another one is through erosion. Okay, so leaching occurs as a result of erosion. Remember, you have different types of erosion. Okay, you have wind erosion, you have water erosion, the one they call gully erosion. So when wind blows all the humus you have on the soil, it blows it away. Okay, and water washes the nutrients you have on the soil top too. So those are the types of erosion that affect the nutrients in the soil. So the next is monocropping. Planting only one crop. Okay, single crop depletes specific nutrients. That specific nutrients required by that crop is going to quickly get depleted in the soil. Okay, another one is compaction. Machinery reduce pore space. When you use machinery, to cultivate, it affects pore space in the soil. Okay, also overcrowding too. Okay, overcropping, too much crop in the soil, it's also part of this compaction. You overcompact the soil. Okay, it's going to lead to a faster nutrient depletion. Okay, so you also have burning. That's why you come now, you burn something for land, just burn bush, no good. Okay, it affects the nutrients of the soil. Okay, it destroys microorganisms. Remember, we talked about the components of the soil, the organic, the inorganic, and so on and so forth. So you can see the effect of burning the soil, or burning bush burning, the one you call bush burning. Okay, so destroy microorganisms, organic matter, and so on and so forth. Let's now understand the method at which we can conserve the nutrients found in the soil, or the method of conserving soil fertility, ensuring that we have a fertile soil. Okay, on the left side of the table we have the methods, while on the right side of the table we have the purpose for that particular method. First of all, let's list all the methods first. We have contouring ridging, we have terracing, we have mulching, we have strip cropping, we have polycropping, we have shifting cultivation, we have crop rotation, we have organic fertilizers usage, we have inorganic fertilizers usage. Now let's take them one before the other. Contour ridging. What is the purpose of contour ridging? To slow water runoff across slopes. Okay, so you will put contour ridging. Put contour. You will not just make it straight. Put contour so that it slows down water runoff. Okay, across where you have slope. All right. So another one is terracing, which prevents erosion on hillside. Where hill dey, you go terrace and it go be like say you put a terrain. Okay, you put step like this, step. So when you have a slope like this, water travels faster in a hill top like this. Hillsides like this, other than when it's like this. When it has steps, okay, it makes water, or it reduces the intensity of erosion. All right, so the next we have is mulching. And what is mulching? Mulching help retains moisture and add organic nutrients. You know what mulching is all about now? Covering crops, okay, or covering the land, okay, to prevent the direct impact of sun on them. Okay, because when the ultraviolet ray is too high, it also affects soil nutrients, and it also affects crops too. All right, so you also have the next strip cropping. Strip cropping is an alternate erosion resistant slash prone crop. You plant crops that resist erosion, especially wind erosion. Okay, crop will get better roots when they resist erosion, especially wind erosion, even gully erosion too. All right, that's strip cropping. You also have polycropping. Planting multiple crops. So polycropping, multiple crops for nutrient balance. If you plant only one crop, it will deplete all the nutrients with that particular crop they use. That particular nutrient will deplete and finish for the soil. So when you polycrop, okay, it's going to help conserve nutrients better. All right. So the next is shifting cultivation. It's a natural fallow. Sometimes there is some textbook will say bush fallowing. All right, it's a natural fallow, restores fertility. Okay, so shift cultivation. Okay, where we say you will leave this land. Okay, you leave the land, you know, we'll plant for this land this year, so now make the land recover. Okay, recover all the nutrients we don't lost. Then after that year, you'll go plant again for the land. That's what bush fallowing or shift cultivation. All right, so the next we have is crop rotation, whereby you plant this crop for this land this year. Next growing season, you know, go plant that same crop again. You go change the crop, you rotate the crop. You know, legume fuses nitrogen to form ammonia because they have bacteria that normally stay in their nodule. Okay, in their, you know, the nodule of legume crop, the root nodule. Okay, so you can see how that kind of crop can help replenish lost nitrogen in the soil. All right, different crops balance nutrients. Okay, that's it. Crop rotation, not just planting only one crop, plant different crops. Okay, so you also have organic fertilizers. Using organic fertilizers, manure, compost, and add humus to replenish the lost mineral or the lost nutrients in the soil. You also have inorganic fertilizer. Remember, organic fertilizer are like manure, compost manure. They add to humus, all right, to increase the soil nutrients, the soil nutrient content. We have inorganic fertilizers such as the one that are manufactured in the laboratory. Okay, the man-made fertilizer. It's not that it's man-made like that, but it's artificial fertilizer. Let's call it artificial fertilizers. Okay, so both of them are man-made, organic. Now man still they make manure, compost. Now man they facilitate them. So artificial ones like the NPK, nitrogen, phosphorus, and potassium. We have urea for specific nutrient deficits. And that's that for that. Now that we have understood soil and its components and everything that has to do with soil, both the particles, the type of soil, sandy, loamy, and clay soil, let's now take some Jamb must repeat questions to further test the knowledge we've acquired so far and check our preparedness for Jamb UTME exam. Jamb must repeat questions. Question 229. Which of the following diseases could be exclusively associated with river basins? A. Malaria. B. Syphilis. C. Onchocerciasis. D. Cholera. E. Poliomyelitis. What's the answer? Give me the answer in the comment section. River basin. Question 230. A larger percentage of tropical soils tends to be acidic because they what? A. Contain larger quantities of potash. B. Contain larger quantities of lime. C. Lost a high proportion of their organic matter to running water. D. Lose lime and potash from the topsoil through rain action. What's the answer? Give me the answer in the comment section, my scholar. Question 235. The following are methods of soil conservation except A. Contouring, A. Contour terracing, B. Strip cropping, C. Contour plowing, D. Mixed grazing. What's the answer? This question is so easy now. I taught you this thing now. So give me the answer in the comment section, my scholar. Question 233. Samples of different soil types are packed in glass tube whose lower end are plugged with cotton wool. If these tubes are suspended in a trough of water, water will rise highest after a few hours in A. Sand, B. Loamy, C. Clay, D. Humus. Was the answer? This is an experimental question. Drop the answer. This is so easy now. Give me the answer in the comment section. It's very easy. Question 234. An indigenous method of renewing and maintaining soil fertility is by what? A. Clearing farms by burning. B. Planting one crop type. C. Adding inorganic fertilizers. D. Shifting cultivation. Was the answer? This is so easy. Don't disgrace me. We just discussed this now. Give me the answer in the comment section, my scholar. Question 235. The soil with the highest water retaining capacity is what? A. Clayey soil. B. Stony soil. C. Sandy soil. D. Loamy soil. Was the answer? Please give me the answer in the comment section, my scholar. Don't disgrace me. This is so easy. Don't disgrace me at this point. Question 236. Which type of soil has the smallest particle and retains water most effectively? A. Sandy soil. B. Loamy soil. C. Clayey soil. D. Humus-rich soil. Give me the answer to this question in the comment section. Why? Because it's so easy. I taught you this not quite long ago now. This exam is closed, so don't disgrace me.